This is a video for AQA Further Pure Mathematics. This is Roots of Equations, section 1.3, in which we're looking at forming equations with related roots. Well, we've seen in previous videos how, for a general quadratic equation, the sum of the roots alpha plus beta is equal to minus b over a, and the product of the roots alpha beta is equal to c over a. What we want to do now is to see how we can find other equations which have got roots which are related to alpha and beta. So here's an example of that then, where we've got the roots of 3x squared plus 2x minus 6 we're told are alpha and beta, and we want to find an equation with roots 3 alpha and 3 beta. As you see there's a question that says, why does it say an equation? If you think about this for a minute, you'll realise that there are several different equations which will have roots of 3 alpha and 3 beta just by having different multiples of each equation. So we can have different values of a, for example. Well, let's look how we can do this then. So we've got the equation 3x squared plus 2x minus 6 is equal to 0. So for that equation we can see that then the sum of the roots alpha plus beta must be equal to negative 2 over 3, and the product of the roots alpha beta must be equal to negative 6 over 3, which of course is equal to negative 2. Now for the new equation we can work out the sum of the roots. That would be 3 alpha plus 3 beta, which is just 3 multiplied by alpha plus beta. But because we know that alpha plus beta is 2/3, this must be equal to 3 multiplied by negative 2/3, which is equal to negative 2. The product of the roots for the new equation is 3 alpha multiplied by 3 beta, so that's equal to 9 alpha beta. 9 alpha beta is then 9 multiplied by negative 2, which is equal to negative 18. So for our new equation, we can say that the sum of the roots, which is negative 2, that must be equal to minus b over a, and the product of the roots, negative 18, is equal to c over a. Now this is where we can choose any value we like for a. So if we let a equal to 1, we therefore have the equation that x squared, we then got b is equal to 2, so we get x squared plus 2x, and c is equal to negative 18, so minus 18 is equal to 0. And that's one equation. For different values of a, then we would get different values or different coefficients for b and c. So there's the solution for that, typed out nicely for you. You might want to pause and just have a read through that to make sure you understand what's going on in that solution. Well, once we've got the two equations, one thing of interest is to have a look at what do those two equations look like if we were to put them onto a graph. Now you can see therefore we've got the black equation there with the roots alpha and beta. So for example we could call this one here alpha and this one beta, and the red equation, or the red line, is the one where we've got 3 alpha and 3 beta. So in future lectures we'll be looking at how we can use the relationship between these two equations to find the related equations by a different method. So it's worth thinking about now, how are those two graphs related? Well, in the second example we've got the same starting equation, but this time we want to find an equation where the roots are alpha squared plus beta squared. Well, we haven't got an equation for alpha squared and beta squared directly. However, if we look at alpha plus beta all squared and multiply that out, you can see that we get alpha squared plus 2 alpha beta plus beta squared. So we can therefore say that alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. But on the previous slide we saw that alpha plus beta was negative 2/3, so this is negative 2/3 squared, and then minus 2 multiplied by alpha beta, which was negative 2. So in total, therefore, we get 4/9 plus 4. When in terms of ninths, that's 40/9 for the sum of the new roots. The product of the new roots, alpha squared beta squared, is just equal to alpha beta all squared. And we saw that alpha beta was negative 2, so this is just negative 2 squared, which is equal to 4. So we've now got a situation where the sum of the roots is 40/9 and the product of the roots is 4. So we can write the equation as x squared minus the sum of the roots, so minus 40/9 times x, and then plus the product of the roots plus 4 is equal to 0. So that's an equation. We may want to sort it out a little bit by multiplying by 9, so that we end up with 9x squared minus 40x plus 36 is equal to 0. Well, moving now on to cubic equations. We've got these results from previous lectures, that the sum of the roots is minus b over a. The pairwise product sum is equal to c over a, and the product of the roots is minus d over a. So here's an example of the sort of thing we may be asked then. We have got a cubic equation with roots alpha, beta, gamma, and we want to find an equation with 2 alpha, 2 beta and 2 gamma. Well, for the original equation it's quite easy to see that the sum of the roots is equal to 5/2. The product of the pairwise product is equal to -1/2, and that the product is equal to -3. Well, looking at the new equation then, we've got the sum of the roots is going to be 2 alpha plus 2 beta plus 2 gamma, which we can simplify to 2 multiplied by alpha plus beta plus gamma. And of course then that's equal to 2 multiplied by 5/2, which is equal to 5. The pairs-wise products are going to be 2 alpha multiplied by 2 beta, then 2 beta multiplied by 2 gamma, plus 2 gamma multiplied by 2 alpha. So this time you'll see we've got 4 times alpha beta plus beta gamma plus gamma alpha. So it's 4 multiplied by -1/2, which is -2. And finally, for the product of the new roots, we've got 2 alpha multiplied by 2 beta multiplied by 2 gamma. So that gives us 8 times alpha beta gamma, which is 8 multiplied by -3, which is -24. So we can see from those then that negative b over a for our new equation is going to be equal to 5. C over a is negative 2, and d over a, or negative d over a, beg your pardon, is equal to negative 24. So we can let a equal to 1 so that the coefficient of x cubed is 1. Then our equation becomes x cubed minus 5x squared, so b is negative 5. C is negative 2, so that is minus 2x, and d is 24, so plus 24 is equal to 0. Again, you might want to just pause and make sure you understand that method that's laid out on that slide. And here we see the relationship between the two equations. Here, the green one, where we've got roots alpha, beta and gamma, and the red one where the roots are 2 alpha, 2 beta and 2 gamma. So again, just think about how are those two graphs related to each other. Well, that's the end of this video, and the next one will be looking at an alternative method to forming equations with related roots, so we'll be doing it by substitution.